I just need it. We agreed, ladies and gentlemen, to say we are not going, or maybe Buleng, I should ask you, are you still doing vectors or you have moved now to Newton's laws?
We started doing calculations, like we're starting to do more calculations.
Calculations on what? On vectors or calculations on Newton's laws?
We are getting introduced to Newton's laws, but we started with calculations.
Okay. I think I get you. I think I get you. Ladies and gentlemen, we agreed. Straightforward. I'm going to be very quick. Law 1, stationary objects and objects that are at rest. Because law 1, ladies and gentlemen, says now an object will stay at rest or continue to move at a constant velocity. So basically what this law says is if an object is at rest, it will be at rest. But it does not necessarily mean that that object that is now at rest, it does not have forces. There are forces acting on it, but those forces are at equilibrium. So you will always have a force. It is a force that is keeping this object stationary. So all the forces acting on this object are now what? Are now equal, and we say they are in equilibrium. However, the law continues to say or continue to move at a constant velocity. What is the meaning of constant velocity? Acceleration is 0. We highlighted that everything it is on this particular slide. So when we say acceleration is equals to 0, we are basically saying the net force is equals to 0. The net force, remember, objects can only move provided there is a force. Let's consider a car. A car can still be moving, cruise control 120, and then nothing is pressed by the driver. However, the car is still moving. Why is the car still moving? Because there's a force of the engine that is allowing the car to move forward. But that force is now locked at a constant velocity of 120 kilometers per hour. What is the meaning of that, ladies and gentlemen? It means there are forces, yes, but those forces acting on the object are now equals to moving now at a constant velocity. So the forces are there. But the fact that it is moving at constant velocity, we say now it is not accelerating. Hence the acceleration is 0, because it is maintaining the same speed throughout of 120. But immediately when the driver now sees the car trying to cross the road, what happens? They apply the brakes, and the brakes now applies a different force, and that car will start to decrease its speed, and we say it is decelerating. If I don't want to be moving at 120 anymore, what do? I press now the accelerator, hence it is called the accelerator, to increase the speed now from 120 to 130, because I'm trying to avoid also the very same car that is trying to cross the road. So the issue of acceleration, deceleration, it is influenced by whether the object was moving at a constant velocity or basically the net force acting on an object is equals to 0. I'm quickly going to go through this. We will explain further as we go. But law 1, ladies and gentlemen, refers to the inertia of an object, which is defined as the resistance of an object to change in its state of motion or rest. When the car is traveling at that 120, we are comfortable and enjoying the ride. However, once there's a car, what happens? The driver now puts on the brakes, and what happens? as the passengers, we move forward and go back to our normal position. So this is now what the resistance of an object to change in its state of motion or rest. Ladies and gentlemen, the factors that affect inertia is the mass. The bigger the mass, the more difficult it is to bring an object to rest. Those that have been watching movies, you can easily tell. If it happens if brakes that are failing, that bus will move until it crashes into the mountain. It is because of its inertia. So the larger the mass of an object, the more difficult it is to move it from rest. But where can we apply law 1? Law 1 says an object will remain at rest or continue in its state of motion unless acted upon by a non-zero resultant force. Where can we apply this basic principle? We can apply those basic principles when we are referring to safety belts. Remember, inertia, you are going to go forward. So if you do not have your seat belt, what is going to happen? You are going to go throughout the windscreen. So the safety belt, it reduces now impact. Let me change this pen. It reduces impact by doing what? By increasing the contact time between the passenger and the dashboard. So the time between you and the dashboard is longer. And when it's longer, what does it do? The net force is reduced. So the impact, how you are going to hit the dashboard, it's now what? Reduced. And then you become less injured. Thank you very much. Ladies and gentlemen, now we go to Newton's second law. Newton's second law, I said to you, it is the most important law ever. This law, we can teach it for about a month at school. I don't want to tell you any other thing because it's such an important concept. It is such an important concept because it includes calculation, free body diagrams, and this is where we can basically collect all our marks. Ladies and gentlemen, the definition of a law. Law 1, law 2, law 3, law 4. We must all know that. There are no half marks, unfortunately. There is no something like in between. It is either you get a 2 or a 0 when we are working with these definitions. So a definition, ladies and gentlemen, is what we need to know. Why do we need to know the definition? Because the definition is a guideline on how to answer the question. It is a guideline on how to give reasons, especially for scientific related problems. Ladies and gentlemen, second law states that when a net force is applied to an object, the object will accelerate in the direction of the net force. Acceleration is directly proportional to the net force and inversely proportional to the mass of an object. I repeat, there is nothing in between. When a net force, so when we have a net force, some books, some material that is out there will say when a resultant force, ladies and gentlemen, is the same thing. When a resultant force is applied to an object. So for us to have an object to move, to accelerate, we need to have a net force. And that object will move in the direction of the net force. And acceleration is directly proportional to the net force. So if net force increases, the acceleration will also increase. However, if acceleration It says acceleration is inversely proportional to the mass. So the bigger the mass, the smaller the acceleration, which makes a lot of sense. For an object that has a lot of mass, it will take time for it to move at a very high speed or high velocities. Consider a bus, consider a truck, very heavy. A truck loads of packages. It will move at 80 kilometers per hour. But when we want the truck to actually somehow move a little bit faster, what do? We take off the packages and leave now the panel to have nothing. So the bigger the mass, the smaller the acceleration. So it is this part where it says it is inversely proportional to the mass of the object. Ladies and gentlemen, we cannot work with Newton's second law without doing what we call draw a free body diagram. We are going to go again into drawing the free body diagram today, but we are going to add values, perform certain relevant calculations. This was a nice summary of what is the difference between Newton's first law and Newton's second law. I am going to update the slide as we go into Newton 3 and Newton 4, such that you can have all your laws as a one-pager for the purpose of summary. Remember, ladies and gentlemen, we are doing 7, others are doing 8 subjects. If you were to sit down and read page by page, you will not finish the curriculum. So I'm giving you these nice summaries for you to have, for you to actually use your mobile phone in order for you to actually revise wherever you are. Hence, our school is a digital school, such that wherever you are, you can be able now to actually be in class and understand the concepts. Ladies and gentlemen, the key bullet here is this one that says free body diagram is needed. So we cannot perform any calculations of Newton's second law if we do not have a free body diagram. That is a skill now. That is a skill lehakwe. That is a skill bullying that you must perfect. Because once we have perfected the skill of drawing the correct free body diagram, ladies and gentlemen, we are home and dry. I explained the difference between contact and non-contact. Contact arises when we have physical contact between the two forces. These are the examples. Non-contact, magnetic force, gravitational force. We explained using an example of an apple to say you throw the apple up, however the apple will come down on its own. Did you touch the apple when it was coming down? No, you did not. Hence we agreed that gravitational force must be now a non-contact force. We said and agreed because, ladies and gentlemen, we are going to what is the word? Draw a free body diagram. It means we must know all the forces that are involved in an object or that are acting on the object. We started, ladies and gentlemen, with what we call the normal force. Normal force is the force or a component of a force which the surface exerts on an object, which it is in contact and which is perpendicular to the surface. I said the normal force will always be there. Why will it always be there? It will always be there provided you have now what? The surface. The surface can be anything, a table, a chair, but the fact that you have now a surface, it means the normal force must be there. Why? The force or a component of a force which the surface, it is not applied by anything. It is applied by the surface. So the surface is actually the one applying the force. So we call it a normal force. It is applied by the surface and it is perpendicular to the surface. We agreed perpendicular, ladies and gentlemen, it means it is making an angle of 90 degrees. With gravitational force, we said is a downward force. So whether the object is going up or down, ladies and gentlemen, gravitational force is always downwards. And we agreed to say it acts perpendicular to the object and with an acceleration of 9.8. So the 9.8 is a constant. 9.8 is a constant, and it will be given in the formula sheet. Ladies and gentlemen, please go to our website, download any paper 1 of physical science or paper 2 of physical science, get those data sheets. The data sheet is not a scandal. It will be given to you. You must practice on how to use that particular data sheet. Very, very, very important. Then we spoke of the frictional force. Frictional force now as the force which opposes the motion of an object which acts parallel to the surface. 2 marks. It's a definition. So now, you must first find or check the direction of the motion. Let's use purple. The direction of the motion is very, very important. Why? Because if our object is moving to the right, frictional force will act in an opposite direction. Hence, the force which opposes the motion of an object. So the motion must be there. So if you are told it is moving in this direction, then it means, let's say this is the motion, then we know our frictional force must always act in the opposite direction. If I am told that this is now motion of the direction of the motion, it means friction must be now in an opposite direction, frictional force. If I am having an object sitting on an inclined plane, moving on a slope there, but I am told it is moving in that direction, what will be, let's say, write it down, motion. What will be the direction of the frictional force? It must be down the slope. Frictional force. Why down the slope, ladies and gentlemen? Friction is a force which opposes motion of the object. So first thing, before you can agree there's friction, you must check 2 things. Do you have a rough surface? Yes. If you have a rough surface, friction is there. First thing is the object stationary? No. Is the object moving? Yes. Then you must check. We have 2 different types of frictional forces. The very first one is what we call the static friction. The second one is what we call kinetic frictional force. Static friction, the force acting parallel to the surface and opposes the motion of a stationary object. So when the object is stationary, friction is there on the rough surface. It's there. But that friction, we call it static friction. Why? Because the object is not moving. Kinetic frictional force. The force acting parallel to the surface and opposes the tendency of a moving object. So the object must be moving. So once the object is moving, it has what we call kinetic frictional force. So kinetic frictional force, ladies and gentlemen, is a frictional force. But frictional force for what? For objects that are moving. And we have our simple way of writing them down. We are going to use Fs. Everything must be capital letters. Fs, S small letter, S for static, so frictional force, static frictional force, and Fk, kinetic frictional force. So hence I'm saying when we draw our free body diagram, when we identify the forces acting on an object, ladies and gentlemen, it is critical and important to use the correct labels. I'm not going to talk to this because I think we can talk about the applied force. The applied force, it is the force applied to an object as either a push or a pull. Very, very, very important. Very, very, very important. Then we had a smaller diagram to say fine. If this is the direction of the motion and then it is pulled in this direction, can I be able to draw a free body diagram? Yes, ladies and gentlemen, I can. How can I? I know I have force applied, which is a pulling force, because it is moving and I'm told it is on the ground. Obviously, the ground, ladies and gentlemen, has what we call, it's a rough surface. Then it means frictional force is there. But was it moving? Yes. Then I must say for Fk, Fn and Fg are always there. Why? Because, ladies and gentlemen, Fn is applied by the surface. What is the surface in this instance? The surface is the ground. Because it is an object, it has its mass. Weight must be acting on it, and weight is now what? Fg. Then this we say it is now just a nice easy surface. I am not going to talk about this problem we did because I want us to look into this one. When I look into this one, there's no question if you check. It's just a statement. It's a statement that says a block of weight 50,9 is at rest. We are told it is at rest on a rough horizontal surface. That is the first part. And check the wording. Rough is in capital letters. Lehakwe, what does it mean automatically, or what is it that the examiner is trying to tell us when they say automatically that rough is now in capital letters?
That the object might not move like very smoothly, or like it might use a lot more energy or like force to pull the object, or like let it move.
Okay, let's take Neo. Neo, why is the word rough highlighted, or everything in small letters, but that rough is written in capital letters? What is it that the examiner is trying to tell us?
That is not on a straight line. It's not on a clean surface.
It is not on a smooth or clean surface. Bullying, what is your take? Why is rough highlighted in this instance? When you see the word rough, it stands out because it is in capital letters and everything else it is small letters. What is your take?
Maybe like the examiner is trying to show that like, or put emphasis on the word rough for you to know that the block is not on a straight surface.
Thank you very much. But everything that you guys said is true. But for me, as a physical science learner, it says to me, once the examiner says rough, once the examiner says rough to me, it means now what? Frictional force is present. It is true. The surface is not smooth, it is bumpy, it is not a straight line because it is everything like that. In actual sense, it must be something like this because most it is the ground. I am not interested in that. I am interested in applying the science to the word rough. The word rough to science says frictional force is present. I don't have questions. I'm going, or us together, we are going to try and do what? Generate questions based on this thing. I don't have questions. And that is the mistake that we are doing, that we want to answer questions instead of understanding the concept itself. If there were questions here, state Newton first law, state Newton second law, each and every one of you will be quick to answer. But I am not teaching you the correct answers. I am teaching you to think, to say, what is the underlying factor when I am working with a problem? How should I go about attending a problem of Newton? So regardless of what is it that you are coming across, if you apply these principles, there's a chance of you getting everything 100% correct. Ladies and gentlemen, because it is Newton's laws, the first question will be, draw a free body diagram. Draw a free body diagram of all forces acting on block B. Okay, let's call it A because we don't have block A. Allow me, ladies and gentlemen, to just name this block A for the purpose of making things easy. And mark allocation is 4 marks. That is now the exam. Ladies and gentlemen, listen to this. Mr. Mazibuko, listen to this. Lehakwe, listen to this. Buleng, listen to this. This thing here, this 4, it's the hint of how many vectors to draw. Once the examiner says draw a free body diagram and it's 3 marks, I must draw 3 vectors, nothing more, nothing less. So basically, the very same mark allocation indicates number of forces acting on an object. Fine. So it is a hint that I'm going to draw 4 vectors. But already it is telling me to say they are, this 4 indicates the number of forces acting on the object. So I must be clever. When I am going to draw, I know I'm going to have 4 vectors. because we agreed I cannot work with Newton's laws if I'm unable to draw a free body diagram. In an exam, the easiest thing will be state Newton's second law, state Newton's first law, but I'm interested in drawing the free body diagram. Bullying, what is a free body diagram? It is a diagram that indicates all forces acting on an object. Now, rule of thumb, we draw a circle. Let's fill it with black. And this now represents an object. We know we have 4 forces. We know. But the thing now, for me not to lose these marks, what must I do? I must draw the correct vectors with the correct labels. Now, Lehakwe give us only one force acting on this particular object.
Frictional force.
Frictional force. Now, let's write that down to say you said frictional force. But the motion of this object, it says when the horizontal force of 10 Newton is applied to the right, the block accelerates to the right. So what is the examiner telling us? The block is moving into the right. Because remember, for me to talk of frictional force, I must have the direction of the motion. Because imagine, I can't have a force going in that direction and call it frictional force. Why? Because frictional force opposes the motion. If it is going to the right, frictional force must go to the left. So it means I am going now to draw to say this here must be something like that. And we know it is a frictional force. So now the question should be, what kind of frictional force is it there? Is it a static frictional force? Sorry, something went wrong here. Let me open it from this side. Are you still with me, guys? Maybe one can open their mic and just say we are here. Neo, can you still hear me? Thank you.
Yeah, I can still hear you. I was just looking for my notes.
Okay, thank you very much. I just want to restore this thing. Looks like it decided to die on us. Thank you. Let's save the new version and call it Newton 11 2024 part 2. I don't know what happened. Maybe it's just us overworking here. And let's go this side. Click here.
So to answer your question, I was gonna say kinetic frictional force.
Kinetic frictional force.
Yes.
I'm not sure what's happening here, but let's start here. Can you see the diagram and the picture and everything like that?
Yeah.
Yes, sir.
Thank you. Then, ladies and gentlemen, let's quickly go straight into it. Lehakwe said it must be frictional force. So Neo says it must be Fk because it is now in motion. Very happy. Now, what other force do we have? We said the question is Draw a free body diagram. Free body diagram of all forces acting on A, and then we set 4. So we agreed rough means there's friction, sharp. Now we are still short of 3 forces. Now which one, the other one that we can put here?
Normal force.
Definitely normal force. Why normal force, bullying? Because remember, we have a surface, so normal force will always be there, because normal force is the force applied by the object, not the object, by the surface on the object, and it always acts perpendicular to the surface. Then we write Fn for normal force. Lehakwe, which one do we have?
Applied force.
Applied force, because we are told that we have a force of applied, and we write now Fa. I usually write 10 newtons in brackets or the value or something like that, but at times it becomes complex because the questions differ. They don't give you the applied force and they want you now to calculate the applied force, but I usually just do it for the purpose of referring to the magnitudes that are given. Now we only have 3, ladies and gentlemen. 1, 2, 3. Bullying, let me put you on the spot. There's one that is missing here. Which one can it possibly be? Just putting you on the spot, because remember we must have 4, ne? Because we agreed to say the 4 in the mark allocation indicates the number of forces. So we only have 1, 2, 3. So it means there's one that is missing. Already it is an indication of how you must approach that particular question. To say, okay, fine. Then it means my free body diagram is not enough. I still need 1 extra force. My free body diagram is incorrect because I've only drew 2 forces. So bullying, just putting you on the spot. Remember, all answers are correct unless proven otherwise. There's 1 force that is missing here. Which one can it possibly be?
Is it not the static frictional force?
Thank you very much. Now remember, static frictional force can either, static frictional force means friction when the object is stationary. So this object is moving. So the fact that the object is moving, it means it will have kinetic frictional force. So this here, it is kinetic frictional force. So you cannot have, and thank you for saying that, you cannot have kinetic frictional force and static frictional force at the same time. You cannot. It's either the object is moving, then you have kinetic frictional force. It's either the object is at rest or stationary, then you have static frictional force. You are right, and thank you for bringing that up, because it is the mistake that majority of our learners will do. The fact that we said it is going to be 4 forces, they want to force any force that is coming to mind to become part of the free body diagram. So now, for us, the people of the academy, we are aware to say, no, fine. When it comes to friction, I have two types, static as well as kinetic. But if the object is moving, then it must be kinetic. If the object is stationary, then it must be static. Then I am happy. But when I draw a free body diagram, I cannot have both of them at the same time. That is another hint for us to know that, okay, fine. Then it means all the forces that I'm going to have are actually the correct forces. I want to have 4. But the 4 that I'm going to have must be the 4 that is going to be correct. Now, Lehakwe, which one is now the remaining one?
Gravitational force.
It is the gravitational force. And that gravitational force, ladies and gentlemen, we call it FW or FG. The W must be small. You can use G or W, it is fine. And ladies and gentlemen, let's read the question again. A block with a weight of 50,96 Newton. This is most our FG. So already the examiner is telling us that the weight is there. FG is there, ladies and gentlemen. So then it means I have correctly identified all of my forces to be now what? To be part of the free body diagram. To be part of the free body diagram. Now, two important equations, let's say three important equations. Remember, the formula sheet will be given. No need for you to memorize this. It will be there. The first equation is Fg is equals to mg. The second equation is Fk is equals to mu k F normal. The third equation is F net is equals to ma. So these are the calculations that we are going to use to perform calculations. But the question will be when and how. You understand? When and how. Because not every equation will be applicable to a certain situation. Some problems will want us to use maybe 3 of them to get to the correct answer, or maybe 2, depending on the situation. Remember, I said this is physical science. It's a dynamic subject. By dynamic, I mean the question, you can take 10 question papers and practice all Newtons in those 10 question papers. The day of the exam, they bring something different, but it's still Newtons. Ne? So we must not focus on getting the practice questions correct. We must focus on what is the skill that I am able to get here. Do I know the skill of drawing the free body diagram? Fine. Can I use the free body diagram to assist me in terms of getting to the correct answer? Because believe you me, a free body diagram is a guideline of how to master and excel in this particular chapter. Now, I'm going to write a question here, which is number B. I will correct these notes. Maybe I can just do it, because now everything is sitting on top of each other, which makes it nasty. yes, draw a free body diagram of all forces acting on A. Then we said this is A. So at B, ladies and gentlemen, I'm just going to say calculate the mass of block A. Calculate the mass of block A. Allow me to take this everything here and move it in a little bit. Fine. Calculate the mass of block A. Let's not put mark allocation. In all the calculations, we must write down the data. A block with the weight Fg is equals to 50,96 Newton. That is the data given. Now with Newton's laws as the hint now. Hint. And please always try to look for that. Please. One variable will always be given. One variable will be hidden, will be given, but hidden. It is there. It is there. So for us to perform a calculation, we need two variables. But one will always be given. It is clear. It is straightforward. You can see it. It's there. It's in the statement. And in this case, we are given Fg is equals to 50,96 newtons. Number one. What is the question? The question is the mass. What other information do I need now? Do you see? I must go and hunt for that one variable that will be given, but it is hidden. And once I can get that variable, is then that I can choose the correct equation. I cannot choose the correct equation just because. One is given, we are given weight. We know the question is the mass. And one variable is given, but it's hidden somewhere. And if it's hidden, ladies and gentlemen, it says to us, apply principles or use data sheet constants. So it is there. The principles will assist you to think and see something. The data sheet will assist you to actually maybe get a specific value, ladies and gentlemen, and everybody else. This object, it's moving to the right. It is still in touch with now what? The surface. Why is it not going in this direction? Why is it not going up? Lehakwe, why is this object not going up? We are told it is moving to the right. My question is, but there are forces. There's a normal force, there's Fw acting upwards and downward. Why is it not going up?
The gravitational force is like holding it down. I don't know.
The gravitational force is holding it down. But what does it mean now about the value of gravitational force and the value of the F normal?
So can you please repeat that?
The gravitational force is holding it down. What does it mean in terms of the magnitude of Fw and Fn when you look at the free body diagram?
That they are balanced.
They are balanced and they are equal to each other. Very, very, very important. Because if they are not equal to each other, what will it mean, ladies and gentlemen? It means this object will move upwards or it will move down. So remember that Fn and Fw, they are always equal in a horizontal surface. Now let's answer the question. Let's answer the question. Let's look at our equations. They said calculate the mass. Ne? Fine. First equation, do we have Fw, Fg here? Yes, we have Fg. Do we have the mass? Yes, we have the mass. Can we get the G? Yes, the G is a constant from where, ladies and gentlemen? From the formula sheet. Then I can look into equation number 2. It does not have mass inside. Ne? Then the chances of us using it, not true. F net is equals to ma. Do I have F net? No, I don't have F net. Do I have acceleration? Yes, I have acceleration. But I will now be working with two unknowns, which is the mass and F net. So that equation cannot be correct. The only correct equation should be now Fg is equals to mg, which is 50,96. We want the mass 9,8 that. Now, the principle said because it is pulling it down, the gravity, it means it has the weight. And that is the reason why I am using the 9.8. Where am I going to get this 9.8? It is a constant from the data sheet. So hence I said, ladies and gentlemen, please ensure that you have your data sheet with you at all times. Any previous question paper available on the website nambaneacademy.com. Download that, use that on your daily activities. Every question that you are going to practice, use that. Why, ladies and gentlemen? Because it will be given in the exam. 50,96 divided by 9.8 is something like m is equals to 5,2 kg. It is the mass, and the mass in paper 1 must be in kg. Very important. Very important. And for this, you can get nice 3 marks. Now, see what is the value or the magnitude of the normal force. 1 mark. Bullying, when you
So?
when you look into the free body diagram, we are assisting you to say we are able to identify the forces. We have the equations, the approach to calculating. You will get the hang of it, don't worry. However, the free body diagram that we draw, it is the one assisting us to answer number B, number C, number D, and number E. Because I cannot automatically think out of my head, ladies and gentlemen. I must use the principles of physics to answer the questions. This question says, what is the magnitude of the normal force? It didn't say calculate. So calculating means formula, substitution, answer, correct SI unit. This one, it is saying what? Just for a mark. Lehakwe, what is the answer for number C?
I don't understand the question.
Let me repeat. What is the magnitude of the normal force? The normal force has a magnitude. What is that magnitude? That is what the question is saying. And where is my answer? My answer is in this free body diagram that we just drew. Assist here, Mr. Neo. What is the magnitude of the normal force? It does not say calculate. It says what?
Isn't it 50,96 newtons?
Thank you very much. Let's check and see how we got into this one, Lehakwe. Remember, we said we are given the weight, which is 50,96 newtons. You yourself, Lehakwe, you said FW is holding it down such that it cannot move upward. So it basically says FW is basically cancelling the F normal. They are equal. That is what we agreed. So it means I am going to use my free body diagram to say but F normal is equal to FW. Why? Because if they were not equal, it means now what? The object must now penetrate the ground. So Fn is there to pull it up, but it's not moving up like we agreed. Why is it not moving up? Lehakwe, you said it yourself. Fw is pulling it down. So the magnitude of Fn and Fw are equal. You understand? So hence we can easily say it is 50,96 Newton. And then we can get now our 1 mark. What did I use, or what did Neo use, ladies and gentlemen? It's very easy. The free body diagram has all the answers that we need. If your free body diagram is incorrect, you are not going to get it right, unfortunately. I'm going to bring another question now. I'm going to bring another question now. I'm going to bring another question. And when I do that, I want to copy this particular slide. The question that I'm bringing now, it's the application of Newton's law. And in this application, I am interested in how are we going to approach this question. I just want to duplicate this page such that you can have both of them because they are very, 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 very important. Ladies and gentlemen, the free body diagram, it is something very, very close to what you believe in. If you believe in him, the free body diagram is very, very close to him. The reason for that is this topic, like I said, it is overlapping grade 11 to grade 12. So allow me to say at number D, calculate the magnitude of the frictional force, kinetic frictional force. Bullying, where do we start? Very easy. You write the data, ladies and gentlemen. FK is the question. What do I have? FW 50,96 Newton. What else do I have? Acceleration 1,6 meters per second squared. What else do I have? I am given force applied of 10 newtons. I'm just writing my data. Please listen to the following question. And bullying, this is now for you. Please listen to the following question. Let me write here. Is the object moving vertically or horizontally?
The object is moving horizontally.
Thank you very much. Ladies and gentlemen, because of that, we are then going to use only horizontal forces. Why? Because the horizontal forces includes the FK inside. So when I look at my free body diagram, the highlighted forces, ladies and gentlemen, are the forces that are going to be part of my, I want to save this thing before it crashes on us again. The forces that I am going to work with are the forces that are horizontal. Why forces that are horizontal? Ladies and gentlemen, this object is not moving up or down. F net is equals to MA. That is the equation that I'm going to use. I cannot use equation number 1, F is equals to mg. Why? Because I have used it most to calculate the mass. Ne? And we found our mass as 5,2. Let me write it down. M 5,2 kg. Fk is equals to mu k Fn. I calculated F normal. We agreed it is 50,96 using the principles of science. But I don't have the mu k now. So it means that question now has what? 2 unknowns. But when I look at this equation of F net is equals to MA, I have the acceleration, I have the mass. Now I must look into what is F net. We said F net is the sum of all forces acting on an object. But now which forces? The forces that are making this object to move. Why to move? Because we are interested in the acceleration of the block. Then we are going to have Fa plus Fk is equals to Ma. I have used a free body diagram to identify which forces are making this object to move. So if my free body diagram is incorrect, maybe let's say I did not have friction there because I did not understand the word rough. Can you see that now everything is going to collapse? Hence the importance of having the correct free body diagram, ladies and gentlemen. The free body diagram, especially like I said for Newton's laws, I can even go back. Allow me to do so, please. Free body diagram, it's NB, to identify all forces acting on an object, and it is under Newton's second law. So every time when I'm going to apply Newton's second law, ladies and gentlemen, it is important to identify all forces acting on an object, but those forces must be in the direction of the motion. Like we agreed, it is moving to the right. So what must I do? It is moving horizontally. What must I do? Look into the forces that are acting horizontally. Hence, those forces are Fk and Fa. Lehakwe, I'm giving you guys 50 seconds to digest everything and drink water, and then we can just get straight into it. Thank you very much, ladies and gentlemen. Now, bullying is force a vector or a scalar quantity?
Force is a vector quantity.
It's a vector quantity, which means it must have magnitude and direction. And because we are working with a force, ladies and gentlemen, we must now tell the examiner to say, I am choosing right as now what? As positive. Why? Because force is a vector quantity. Then it means all the forces in this direction must be positive. So my Fa will be positive. Fk will be minus. Mass is a scalar, and then acceleration also will be in the same direction because we agreed that it is moving to the right. What is the value of Fa? 10. Fk, it is the question. What is the mass? 5,2. What is the acceleration? 1,6. Then what do we do, ladies and gentlemen? You take your nice scientific calculator and you say 5.2 multiplied by 1,6 gives you something like 8,32. 8,32. 10 minus Fk, and then if you do your mathematics, Fk is just 10 minus 8,32, and then minus 10. The answer here becomes something like 1,68. Then Fk is 1,68 newtons. 1,68 newtons. Lehakwe, questions please.
I understand so far, sir.
Thank you very much. Mr. Mazibuko, questions please.
Nothing so far, thank you.
Bulem Motlo, questions please.
No questions, sir.
Thank you very much. Ladies and gentlemen, the following question says now, calculate the coefficient of friction. Calculate the coefficient of friction. 1, 2, 4. Coefficient of friction. Coefficient of friction, we are talking about mu k. The mu k, we call it a coefficient of kinetic frictional force. What is mu k? Mu k, it is just the amount of how much friction can the surface provide. So mu k changes and differs from now what? Surface by surface. If it is very small, it means the friction will be less. If it's very high, the friction will also be very high, because it is now the measure of how much of friction can be produced. Now there's only one equation there that has mu k. Please, ladies and gentlemen, allow me to put it there for the purpose of space, and I don't want to duplicate this thing anymore because this is the last thing we are going to do. Now the equation says Fk is equals to mu k F normal. Ne. Fk, we calculated 1,68. Mu k, it is the question. Now Lehakwe, imagine if you did not understand how to get the value of F normal. You see, everything was going to collapse. We needed the free body diagram to inform us that this thing is also 50,96. Why? Because the Fn is pulling up, Fg is pulling down, but this object is not moving either down or up. It's moving horizontal. So it means Fn and Fw, they are actually now in what? In equilibrium with each other. Then it means if I have Fw, it must be the same magnitude as that. then this must just be 50,96. Ladies and gentlemen, I did not complicate the science. I only used a free body diagram for me to actually answer all the questions that are coming up. Hence, I did not write questions here. When I took the snapshot of this question, I said, I'm not going to ask these questions because questions are going to differ. I'm just going to coach you on how to apply a critical thing, how to use a critical thing that is called now what? A free body diagram. Lehakwe, reflections, please.
I understand everything so far. Thank you for explaining decently.
Thank you very much. Your Excellency, Mr. Newo.
I enjoyed the lesson today. It was really nice. You coached us how to answer a question very easily. Thank you.
Thank you very much. Bullying, it was your first time here. Welcome. Maybe you saw how we did things. What were your expectations? Have they been met? Do you think that you are going to be with us until the end of the year, provided how we are doing things here? Because as individuals, we can also improve. Reflections, please.
I think I will be like here until the end of the year, maybe like next year. And today's class is good. I actually understood a lot more than I actually thought I knew. And yes, my expectations were met. Thank you for asking.
Thank you. So what I'm going to do, ladies and gentlemen, I'm not going to give you any homeworks as yet. We'll most probably start with homeworks next week, because I am sensing that we are still going to get more of grade 11s coming in. So what I'm going to do, I will share the e-notes for you just to get the concepts. Those that are coming, I will have a separate session to put them onto speed. Then when I have a minimum of 5 people, if I can have 5 people here, then we are no longer taking more, because that is now our target. So there's only 3. So tell a friend, recruit somebody else. If we can be 5 or 6, I will be very happy. Then we can be able to continue positively the best way we can. Ladies and gentlemen, I'm going to share the e-notes with you. We'll probably do it after 8, but you'll definitely get them before the end of the day. Remember, if you want the recording, please tell me. I will share the link for you to be able to watch the video separately on our cloud space, because I'm not going to put them on my YouTube channel soon. I will put them towards the end there when everybody is in need of everything. Ladies and gentlemen, thank you. Have a lovely day. May the great Lord give you everything that your heart desires, and give you strength to actually understand the maths, the science, and all the subjects that you're doing. Let's meet again tomorrow at exactly 17:45. Thank you very much, and have a lovely day.
Bye.
Bye. Thank you.
I thank you, sir.